Ever torn off the protective foil under the cap of a new bottle of vitamins? Then you've seen firsthand a result of induction heating. Induction heating helps heat the foil so it adheres to the bottle. It's a common application used in commercial food and drug manufacturing as a way of applying safety seals, like those on vitamin and medicine bottles. Induction heating has been around for decades and is an efficient method for heating metal parts. Its traditional uses are many. Now, induction heating is being successfully used in industrial and construction applications involving welding, such as preheating before welding and stress relieving after welding. Let's look at what happens in induction heating. When electrical current flows through a conductor, it produces a magnetic field around the conductor. By alternating the current, the magnetic field is reversed. Placing a conductive material, like metal, in the alternating magnetic field causes the material to heat up. Here's why. Localized electrical currents called eddy currents are created within the metal. The metal has a certain amount of electrical resistance. The circulating eddy currents flow against the metal's resistance, causing it to heat up. Another contributing factor to heating is hysteresis. This occurs due to the material's resistance to the changing magnetic field. Eddy current heating provides significantly more heating than hysteresis. Now, let's look at a typical induction heating system for preheating or stress relieving. Induction heating uses a conductive cable, which can be wrapped around or placed on a metal part to be heated. Alternating current passes through the cable, creating a magnetic field in the part. The reversing magnetic field creates eddy currents and hysteresis in the part, which, as previously mentioned, creates heat. Induction heating is unique, as compared to most conventional heating processes used for preheating and stress relieving of welds. It is a non-contact method of quickly heating metal by inducing current in the part. Therefore, it does not rely on a heating element to touch the part to conduct heat, or a flame to impinge on the part. Essentially, the part becomes the heating element, and the highest temperature is generated and controlled in the part rather than the heating device. This process of heating makes induction highly efficient and extremely accurate.